Alright guys, so what we're going to be working on today, we're going to be working on help on Webassign 3.3. So the first question that I noticed a lot of us haven't gotten correct yet is number 11. It says, consider the function on the interval 0 to 2 pi. It says, find the open intervals on which the function is increasing and find the open intervals on which it's decreasing. Well, this is a classic take the derivative situation. If I want to know when something is increasing versus decreasing, I need to take the derivative, find its critical values, and do a first derivative test. So the derivative here, f prime of x, is going to equal x over 2 is the same thing as 1/2 x. So the derivative of 1/2 x is just a half, plus the derivative of cosine, which is just cosine of x. I want to know when does this equal 0. So I'm going to subtract a half on both sides. And this should hopefully bring us back to our pre-calc days. When does cosine of x equal -1/2? Well, I'm asking when is the x value equal to -1/2? That happens down here. And it happens down, oh, no, it actually doesn't, my bad. Happens down here. Let's actually go back a couple. It happens here, and it happens here. So it's going to happen at x is equal to 2 pi over 3 and 4 pi over 3. Let's go ahead and do a number line to determine where everything's going to be increasing versus decreasing. So 4 pi over 3. All right, so if I plug in a value that is to the left, and remember we're on the interval 0 to 2 pi, so 0, 2 pi here. All right, so if I plug in a number that's between 0 and 2 pi, like over here, I know that my cosine values here are going to be, if I plug that in, I just want to go ahead and solve this actually. Well, I guess I'll just plug something in. If I plug in cosine of something less than 2 pi over 3, I should get something that is positive or less than a half. And so I know that that's going to be positive. All right, so if I plug in a value that's after 2 pi over 3, so something down here, cosine's going to be negative and bigger than a half, and so that's going to be negative. If I plug in a value up here, it's going to be positive. And you can use your calculator to check that. So it wants to know when is the function increasing and decreasing. So for increasing, it should be increasing from 0 to 2 pi over 3, and from 4 pi over 3 to 2 pi. It should be decreasing in the middle, so from 2 pi over 3 to 4 pi over 3. Okay? And so those are the answers for the first part of question number 11. Second part, apply the first derivative test to find relative extrema. Okay, well, to find relative extrema, if I'm going from increasing to decreasing and decreasing to increasing, I know that there is a relative max at x is equal to 2 pi over 3 and a relative min at 4 pi over 3. So I have a max at x is equal to 2 pi over 3 and a min at x is equal to 4 pi over 3. All I want to do here, they want to know what's the y value. So I know for sure the x value is going to be 2 pi over 3 and the y value is going to be 4 pi over 3. To find, and the x value there. To find the y value, I just need to plug back into the original. So x over 2 plus sine of x. And I want to know, hey, what's f of the first value? Let's see, 2 pi over 3. Let's find that. So f of 2 pi over 3 is going to be equal to 2 pi over 3 divided by 2, or I could say times a half, plus sine of 2 pi over 3. So sine of 2 pi over 3. Sine of 2 pi over 3 is over here, and that's radical 3 over 2. And so I'm going to get, this actually is going to cancel here, I'm going to get pi over 3 plus radical 3 over 2. So we can say pi over 3 plus radical 3 over 2. Let's go ahead and find out f of 4 pi over 3. So f of 4 pi over 3 is going to be equal to 1/2 times 4 pi over 3 plus sine of 4 pi over 3. Okay, well, sine of 4 pi over 3 is going to be negative. This is going to cancel, so we're going to get 2 pi over 3 plus the sine of 4 pi over 3 is negative radical 3 over 2. So I'm going to get 2 pi over 3 minus radical 3 over 2. And that's the solution for letter C. And then for letter C, you're just going to confirm your results by graphing. All right, next one. This is number 12. Consider the function on the interval 0 to 2 pi. Find the slope. Find the open intervals in which the function is increasing and decreasing. So once again, let's do a first derivative test. I'm going to take the derivative. F prime of x is equal to cosine of x minus sine x. I want to know, when does this equal 0? Well, a good question for this is, when does cosine x equal sine x? When do they have the same value? Well, that happens here at pi over 4. That's radical 2 over 2, comma radical 2 over 2. And it happens here at 5 pi over 4, which is negative radical 2 over 2, comma negative radical 2 over 2. So I have the same x and y value. So the answer is going to be x is equal to pi over 4 and 5 pi over 4. To find out when it's increasing or decreasing, I'm going to make my first derivative test. I'm going to label it f prime of x. I'm going between 0, pi over 4, and 5 pi over 4, and 2 pi. And let's go ahead, plug back into the original function and see what we get. If I say cosine of something less than pi over 4, so cosine minus sine, well, it looks like the cosine value, the x value is bigger, the y value is smaller, so that's positive. If I go up here, the x value is smaller, the y value is bigger, so that's going to be negative. I don't know why it's not processing that. Give me a sec. All right, that one's going to be negative, and the next one will be positive. And you can verify that on a calculator. I know some of us, our trig skills could probably be, they could be improved. All right, so when is it increasing? Well, it's increasing from 0 to pi over 4, and then it's also increasing from 5 pi over 4 to 2 pi. It's decreasing from pi over 4 to 5 pi over 4. Okay? It says apply the first derivative test to identify relative extrema. Well, if I go from increasing to decreasing and decreasing to increasing, I have a relative max at pi over 4, and I have a relative min at 5 pi over 4. To find the y value, I'm just going to plug in pi over 4 to the original. So f of pi over 4 is equal to sine of pi over 4 plus cosine of pi over 4, which is going to be radical 2 over 2 plus radical 2 over 2, which is 2 radical 2 over 2, which just cancels to radical 2. So that one's radical 2. If I say f of 5 pi over 4, I'm going to get the same thing except negative. So that's going to be negative radical 2 over 2 minus radical 2 over 2, which equal negative radical 2 over 2, negative radical 2. All right, so that one is number 12. All right, let's keep on going. We're going to skip number 14. All you need to do for number 14, just get your table out on your calculator or plug it in using y sub 1 and just kind of get approximations here. So to get the first approximation, you're just going to evaluate what's c of 0.5 and then what's c of 1, et cetera, et cetera. Okay. All right, let's keep going. All right, it says use a graphing utility. Once again, you can just graph this on your graphing calculator. Pick the graph that looks most similar. And then you're just going to use your calculator, use calculus to determine analytically when the concentration is the greatest. So basically what you're going to do is you're going to find the maximum on your calculator. So to find a maximum on your calculator, I'm not sure if this is going to show up on the screen or not, but I'll show you. I'm about to sneeze. No, maybe not. To find a maximum on your calculator, there's actually a function for it. So if I put in this value, I say 9x divided by the whole thing, 64 plus x cubed. If I graph this on my calculator, let me go ahead and zoom standard because I was just doing trig stuff. Okay. So what I'd like to know is when do I have a maximum, when do I have a minimum value? So what I can do to find a max or to find a min, relatively speaking, is there's actually a trace button and it says minimum and maximum, and you can use that just like you would use a 0 button to identify maxes and mins. So that's what I would do there. Okay. So yeah, that's what I would use there, is just the max and min button. All right, lastly, this one is very, very applicable, I guess, to our everyday lives. It says coughing forces of the trachea to contract, which affects velocity v of air in the trachea. The velocity of air during coughing, wow, corona, is equal to, well, v is equal to k times r minus little r times r squared, where little r is between 0 and big R, where k is also a constant and r is a normal radius of a trachea. It says, what radius r will produce a maximum velocity? Okay, well, all I want to do here, take the derivative Set it equal to 0. That is literally the bread and butter of this right here. All right, so r and k, we can treat those as constants. So we're going to go ahead and take the derivative here. Okay, so before I take the derivative, I just want to make sure that this derivative is really easy to take. I don't really want to use product rules, so I'm just going to distribute everything in. So if I distribute the k in, I get k capital R minus k lowercase r all times r squared. I'm going to go ahead and distribute the r squared in. So I get k r little r squared minus k little r cubed. Remember that little r is the only variable here. K and r are just constants. So if I took their derivative, they would be 0 if they were by themselves, which they're not. B prime is going to be equal to 2k r minus 3k r squared. So notice here, the only thing I'm treating as a variable is r. Think about k as like a 2 and r is like a 10. They're just numbers. And so I want to know, when does this whole thing equal 0? Well, what I could do is I could factor out an r. And I guess I also could factor out a k. So what I get is 2 minus 3r is equal to 0. So 2 minus 3r is going to equal 0. So what I'm going to do here is I want to set both pieces equal to 0. Well, I know r can equal 0 using zero product property, and 2 minus 3r could equal 0. So 3r is equal to 0, and is equal to negative 2. So r could equal 2 over 3. I'm going to go ahead and create a first derivative test and find out, hey, where is the maximum going to occur? Well, if r is equal to 0, that number doesn't make sense. I can't have a radius of 0. That would mean that I would have literally no tracheus radius at all. So I guess that value wouldn't make sense. Let's just make sure that that's defined. R is the radius during coughing. So I know I'm not going to have a radius of 0 when I'm coughing. Otherwise, I would be choking. And so 0 is out. We just want to test, is 2/3 going to be a maximum? Well, by plugging a number to the left into the first derivative, so remember this right here is the first derivative. If I plug in a number to the left, like say I plug in negative a half. Okay. If I plug in like negative a half, I'm going to get negative half on the outside, and then 2 times 3 times a negative is a positive. And then after that, if I plug in a real big number, like say like 100, I'm going to have 100 times k, and then I'm going to have 2 minus 3 times 100. That's going to be a negative number, right? So negative 3 times 100 is negative. So negative times a positive is a negative. And so I can see right here, there is going to be a maximum value. It goes from positive to negative here at 2/3. So r is equal to 2/3 is going to be your maximum radius. Okay, guys, real quick correction. Actually, I forgot to put this r in here, so I'll do it another color just so you can kind of see. Forgot the r right here. So that r is going to translate to being here, being here, being here. So at the end, it's actually going to be 2/3 r. My bad, I forgot about that r there. All right, so those are all of the questions that it seems like it's going to take you guys to get up to that 75% that you need. If you're still struggling with this after watching the video, please just send me a reminder and we can meet today to go over any Webassign questions that you have. All right, if I don't see you guys, I hope you guys have an awesome break and stay safe. Get some rest.